This is sound. So what were we discussing yesterday? Area of a triangle. So minors and cofactors we have completed. I discussed with the first class, you remember? Because I wanted to connect minors and cofactors to the concept of determinants. Now what I told you about determinants. So generally when you talk about determinant, many people think that is a cross multiplication thing. But what is it actually? I gave you the definition. Can you tell me what is it? Can you tell me what is it I gave you? Subrajit, can you tell me what it is? What is determinant? Product of elements. So it is actually the sum of product of elements with their corresponding cofactors. Right. So we discussed about minors and cofactors. So when you want to define minors, let's try to recollect it. So if you want to define the minor of a matrix, right? Then how do you get it? So if you, not minor of a matrix, if you want the minor of an element, minor can be defined only for matrices whose order is greater than or equal to 2, right? Greater than or equal to 2. If that is the case, then what is the minor that is obtained for a particular element? If I have a 3 cross 3 matrix, as an example, a determinant of 1, 2, 3, 4, 5, 6, 7, 8, 9 if it is there, I want to find the minor of element 6. Then what am I supposed to do? I need to hide the corresponding row and the corresponding column. Then I'll be left out with what matrix? 3 square. Then what square matrix of what order? I will be left out with the square matrix of order 2, and that order 2 square matrix, whatever is left out, is what is called as minor or cofactor. It's called minor. So minor is basically the determinant that you obtain by ignoring the corresponding row and the corresponding column of which element you're trying to construct. So in this case, what will be the minor matrix? Or what will be the minor, This is cut and this is cut. You will be left out with 1, 2, 7, 8. For online guys, am I audible? Right? Then what is the determinant of this one? 8 minus 14, you are going to get minus 6. Right? So minor is going to be a number which is obtained by finding the determinant of that square matrix which you obtained by ignoring the elements in the corresponding row and the corresponding column. I hope this has got registered right. Then what is a cofactor? How are cofactors and minors related? So cofactor is exactly the same as the process what you follow in minor, except the fact that you need to multiply with a prefix. What is it? So you will multiply the minor of ij with minus 1 raised to the power of I plus j. Then you can call this as capital Ij. Capital Ij is called as the cofactor of the element which belongs to the ith row in the jth column. Is it clear? Is it right? So when we define determinants, we try to define it in terms of elements and cofactors, not elements and minors. So this is the place where I've seen people getting confused. So minor, you will not have negative or positive sign. You don't have the prefix of minus 1 power I plus j. Whereas for cofactor, you have that minus 1 power I plus j. If you miss it, you're gone. Is that clear? So please start doing problems based on this. So do example 20. Find the minor and cofactors of all the elements of the determinant. It's a 2 cross 2 matrix. So minor of, I think this problem we did it, no? But parallel, we'll do it again. So minor of first row and the first column, the element which belongs to it is correct. M12, first row, second column, 4, correct. M21, M22, 1. Then what about the cofactors? It is minus 1 power into 3. Is there anyone who is not able to understand? So minus 1 power 1 plus 2 into 4. Minus 4. Then what about A21? Minus 1 power 3 into minus 2. It is 2. And A22 is minus 1 power 4 into 1, which is 1. Is it right? Okay. So do example 21, do it fast. Try it. It's slightly complicated. You need to deal with symbols, that's it. So be cautious. Ram, can you come? Ram. Inverse trigonometry papers mostly I try to give it by tomorrow. Okay. I want to see your notes. Easy that, huh? Easy that, huh? Be clear with the symbols, okay? Okay, proceed. Don't wait for me. Next book, yeah. Okay. So those who are able to do, proceed. Don't wait for me. 22. Find the minors and cofactors of the elements of the determinant. So those are online. Are you doing it?
Yes, sir.
Hamsini, Harish, Harini, Harshavardhan, Harshita, Nitish, and Srinidhi.
Sir.
Yeah. So find the minors and the cofactors of the element. So they have given this thing. No, 1 minute. I have a question. They have given element multiplied with cofactor. No, A11 into A31 plus A12 into A32 plus A13 into A33. Can I call that as determinant? What did we say determinant is? Multiplication of elements and cofactors. So can I call it as determinant? Yes or no? Right? You cannot call it as determinant just because elements and cofactors are multiplied. The cofactors are supposed to be the cofactors of that particular element. So A1 to A11 should have got multiplied with capital A11 for it to be called as determinant. Okay, be careful about that point. So let me know if you're done with this problem. Done now? You have textbook. Proceed. Exercise 4.4. Can this be completed in 10 minutes? Can you do this exercise in 10 minutes? We will go to the next one, adjoint. So write the minors and cofactors of the elements of the following data. Yes. What do we do for second sum? Write the cofactors of elements of second row. So elements of second row are what? 201. This one, no. So A, what is this element? 2. But what is the count of that element? It is in the second row, first column. So A21 will be equal to minus 1 power 3 into M11. Sorry, M21. Up M21 evolo? Hide this and hide this. You are having 3823. So find this value and multiply it here. That will be the answer. Similarly, do it for 0. Similarly, do it for 1. Can you do that? No. Using cofactors of Hey, 1 minute. It was my mistake. I didn't read the question properly. I didn't read it. I thought they're asking you the cofactors. So I'll do this problem. Wait. Cap anga irukada? I'll take it. Leave it. I'll take it. So using cofactors of elements of second row, right? Evaluate determinant. So what is the determinant? That is going to be A21 into capital A21. Huh? Delta. Delta is determinant. Area is just area. They have actually in your textbook, they have used delta there also. But I suggest you to, so I'll show you, see. They have used the same symbol here. That is actually confusing. So I would suggest you to use this as area only. The symbol for determinant is delta. Like there are two deltas, right? One this and one is this thing. So you will be using a triangle delta for using the determinant. So you go with it. Generally, what happens is they both do not exist at the same time. That is why they would have given delta. But I suggest you to go with area. Okay. A21 into capital A21 plus A22 into capital A22 plus A23 into capital A23. So A11 is 2. What is capital A21? First, let's find capital A21. Capital A21 is minus 1 power 3 into M11. Tell me what is the value of it? 7. Minus 7 or 7? 7. Okay. A22 minus 1 power 4 into M22. Adu 7 then. Okay. What about A23? Minus 1 power 5 into M23. So minus 6. Okay. 7 related. Minus 7. Now you know what is A21. A21 is 2. A22 is 0. A23 is 1. So multiply these two. 14 plus multiply these two. 0 plus multiply these two. Minus 7. So 14 minus 7 is 7. That is the answer. So you can find the determinant in any method you want. They wanted to find the determinant only with the help of the elements in the second row. Purida. So this is what they expected. Using the same logic, can you guys do the fourth problem fast? Do it fast. So using the cofactors of third column, evaluate the determinant. So what is M13, guys? First row, third column, then. So what is M13? Z minus y. So it is Z minus y. M23, Z minus of Z minus x. Minus of Z minus x. M33 is, sorry, y minus x. So cofactors we got, multiply them. Yz into Z minus y plus Zx into, actually minus 4, minus Zx into Z minus x plus xy into y minus x. So what do you get? Yz square minus y square z minus z square x plus zx square plus xy square minus x square y. Are there things that are getting cancelled? Nothing. Huh? X square into z, x square into z minus y. Okay. I think you can leave it as it is. I think you can leave it as it is. Is that how the answer is left out? Their factor is it. Did they write it as product of two factors? They wrote it as product of three factors. Then we need to use our algebra skills. Okay, I'm taking y from here, y into z square minus x square minus z into y square minus x square plus x into y square minus z square. I don't think we can simplify it beyond this. Did they? A square minus b square use பண்ணலாம். Just a minute. Okay. So can I take out z common from both? If I do that, what am I going to get? Z into yz minus y square minus xz minus x square. Plus x square plus xy into y minus x. Okay. So z into, from these two things, I'll take z outside. Then I'll get y minus z. Sorry, y minus x. Is it right? Minus of y square minus x square into y minus x. Can I do this? See, actually, after I complete, I'll tell you. Z into y minus x minus of, how can I write this as y minus x into y plus x plus xy into y minus x. Can I do this? So here, and here, what is common? So if I take out y minus x outside, I'll push the z inside. So I'll get z square minus z into y plus x plus x square. Okay. So y minus x into z square minus zy minus xz plus xy. Is this how they gave? Okay. So what is that what they gave? I think you need to again factorize this. Yeah. So y minus x into, if I take the z outside, then you will have z minus y minus x into z minus y. I think we got it. Right. So y minus x into z minus x into z minus y. Is that what they gave? As a cyclic pattern, like x minus y, y minus z. So if I take the minus sign outside, x minus y into y minus z into z minus x. This is the answer. Okay. But to be honest, you need not do all these things. You can just write the expanded form and leave it. You need not do this. Just to match the answer it, right? So this is all about factorization. Surya. So based on this, fifth problem is easy, guys. So tell me. 30 seconds time. That's it. Elements with corresponding cofactors. Right? So this is how the answer is. Next is adjoint and inverse of a matrix. This is the last concept of this chapter. Right? So basically, when you talk about inverse, I would have already told this to you. There are two kinds of inverses that exist. Right? If I talk about inverse of a number, if I put a question like this, I give you a number as root 3, which is an irrational number. I say, tell me the inverse of root 3. What will you say? That's what I expect. You should ask the question of what inverse I'm trying to talk. Because there are two kinds of inverses that exist. One is called as additive inverse, and the second is called as multiplicative inverse. So what is the additive inverse of root 3? Minus root 3. Why do we call it as additive inverse? Because when you add a number to the original number, the output should be a 0. Then you call that number as additive inverse. Meaning, minus root 3 is additive inverse of root 3 and vice versa. That is, root 3 is additive inverse of minus root 3. Means they are basically conjugate of each other. Right? I cannot call it as conjugate because generally you speak about conjugate only for surds. That is when you add a rational and irrational number, when you take it to that form. But I hope you are able to understand, right? Which one? 0 is additive identity. That's what you can take it like that. Yeah. So you can still call them as conjugates if you write it in 0 plus root 3 and 0 minus root 3. That is okay. If suppose I ask you what is the multiplicative inverse of root 3? The reciprocal of it. Provided that number is not a 0. So 0 doesn't have any multiplicative inverse, correct? So in the case of a matrix also, you have something called as inverse of a matrix. Meaning is, when you multiply two numbers, you expect the output to be 1 for them to be called as multiplicative inverses. Means numbers are multiplied, output is also a number. 1 is a number, a real number. Right? Whereas when you multiply two matrices, the output is always a matrix. Have you ever seen a scenario where you multiply two matrices and you get a number? Recollected from previous chapter. When two matrices are multiplied, the output is also a matrix. Right? So when you talk about inverse of a matrix, first thing to be noted is it is applicable only for a square matrix. Okay? It is applicable only for a square matrix. Why is it so? You will understand it soon. Secondly, when I say inverse of a matrix, I am trying to speak about the multiplicative inverse of a matrix. Meaning, if I multiply a square matrix A, then if I multiply it with the inverse of it, A power minus 1, which you read it as inverse of A, the output will be a matrix. And what matrix is it supposed to be? It will be an identity matrix. Means the diagonal elements will be 1. All other elements other than the diagonal elements are zeros. Right? If this kind of a scenario exists, then you call it as inverse of a matrix. I think I've already explained this in the previous chapter also. Because we saw one concept. If at all inverse of a matrix exists, it is always a unique value. There is a theorem also which I discussed.
There should be a condition like
no element of
the matrix which we are identifying as should be 0.
not even a single element.
Yes.
Single element.
So then if suppose one of the diagonal elements.
Yeah. You are saying diagonal elements or one of the elements?
So one of the. So if diagonal.
See, if I take a 2 cross 2 matrix, okay, 0, 1, 2, 3. Since 0 is here, you mean to say inverse doesn't exist. Because when you do product, what you do, you multiply the rows and the corresponding columns and add them. No? Got it? You do the dot product if I have to be more specific. Dot product of vectors section. After I explain that, I'll explain what is matrix multiplication 3B. Are you able to understand till this point? So here, inverse of a matrix means I'm trying to find the multiplicative inverse of a matrix. Is it clear? Now, so to find the inverse of a matrix, there are basically two techniques. One is you can perform certain mathematical operation within the matrix and find the inverse. That is called as elementary operations of rows and columns, which we didn't discuss in the previous chapter because it is deleted. And it is one of the complicated process also. There is no use of you learning it also. Even if you have to do it for some exam, except for subjective part, it is not going to help you in any objective also. So that part can be completely ignored, not a big deal. Okay. Secondly, you can find it using a method called as using adjoint of a matrix. So what is adjoint? To understand what an adjoint is, you need to have the clarity of cofactors. So by now, I hope you guys are clear with what is the cofactor matrix. We did around 8 to 10 problems, right? Now, if I have to say what an adjoint of a matrix is, so first thing, adjoint of a matrix again exists only for a square matrix. Okay, because all these things are related to finding the inverse. And since you're discussing in this chapter, we need to involve determinants also into consideration. So since determinants are coming, determinants are only applicable for square matrices. So you might get confused many times because we are dealing with many matrices. So you can have these kind of points to think of. So adjoint of a matrix, you first find the cofactor matrix. So if suppose I give you a square matrix, you know how to find the cofactor of all the elements. So you write you replace those elements with the cofactors of those elements and find the transpose of it. I repeat, transpose of a cofactor matrix is what is called as adjoint of a matrix. Is that clear? Okay. So what we are supposed to do is the adjoint of a square matrix capital A is defined as the transpose of the matrix capital IAIJ. Means observe. In the square matrix A, what are the elements? Small a ij. Whereas in the adjoint matrix, what are the elements? Capital Aij. What are capital Ij? Capital Aij and another cofactors. So you write down the cofactor matrix and find the transpose of it. You call it as adjoint of that matrix. Let me get into an example itself. If I take A is equal to 1, 2, 3, 4. You know what is the transpose of the matrix, right? Interchanging the rows and the columns. So 1, 2, 3, 4. If I have to write the cofactor matrix, then what will it be? So first write down the elements. 4, 3, 2, 1. You didn't put the sign. You wrote the minor matrix, not the cofactor matrix. Four minus 3 minus 2, 1. This is the cofactor matrix. Right? Now write the transpose of it. So cofactor matrix transpose is what? 4 minus 2 minus 3, 1. Then this is what is called as adjoint of the matrix. So what are the steps to be followed? First, you look at the square matrix that is given to us. You write only the cofactors of that particular matrix in the corresponding order and then find the transpose. You do that, you found the adjoint. So once the adjoint is found, how to find inverse, we'll go to the next step. We'll see it in the next step. Can we try out few problems based on this? I did for a 2 cross 2 matrix. Can you try it for a 3 cross 3? Is there anyone having a doubt in this? So I'll tell you the steps to be followed. Okay. So, okay. Find, see, adjoint is represented with the short form ADJ. ADJ represents adjoint. Don't read it as adjacent, but yeah, adjoint. Okay. So adjoint for A is equal to 2, 3, 1, 4. Find it. Sorry, adjoint for matrix A. What is the cofactor matrix? It's looking something similar to what I took. So 4. First, write down the minor. Okay, 4 1, 3, 2. So plus minus minus plus. So this is the cofactor matrix. What is adjoint then? 4 minus 3 minus 1 2. புரியுதா? தருஷ் புரியுதா? எந்த பாயிண்ட் டவுட்னு சொல்லுங்க. எந்த ஸ்டெப் புரியலன்னு சொல்லுங்க. லாஸ்ட் ஸ்டெப் மட்டும் புரியலையா? அதுக்கு முன்னாடி புரிஞ்சதா? You understood how to find the cofactor. So cofactor, after you find the cofactor matrix, take the transpose of it. Transpose எழுதும்போது என்னன்னா diagonal elements are undisturbed. இந்த மாதிரி ஒரு லைன் போட்டனா you can write those elements to be the same. Only the elements on the other side get swapped. So அதனால -3 இந்த பக்கம் வந்துருச்சு. Sorry, -1 came this side, -3 went to the other side. Is it clear? So write it down. Right. Shall we proceed with the 3 cross 3 matrix? Okay, first write down the adjoint for this. 133, 143, 134. 133, 143, 134. So take those numbers and write them. Just write adjoint, don't think anything beyond that. First Did you get the answer? So we'll cross verify since I didn't do it. What is the answer? 7. This is the cofactor matrix or adjoint? Adjoint. Okay, 7 minus 8. -1, 1, 0. Is this what everyone has got? Right? No, only everybody is silent. Guys, are you doing it? Those who are online, are you doing it?
Yes, sir.
So this is the adjoint of A. Okay. So the last point that I'm going to tell you is, if you want to find the inverse of a matrix, A inverse, right? Write down this formula. Why this is coming and all, I'll explain in the next class. Okay. If you want to find the inverse of a matrix, you can find it using the concept of adjoint of a matrix and divide it with the determinant of that matrix. Okay, this you can call it as a formula or expression or whatever you want. Inverse of a matrix, there is only one method in your syllabus currently because the other one is deleted. Inverse of a matrix is find the adjoint separately, find the determinant separately, and divide both, provided determinant of A is not equal to 0. It is something similar to rational numbers only. Except the fact the numerator is a matrix, adjoint is a matrix, and determinant is a number. So you're dividing a matrix with a number. Okay, so have this in your mind. Next class, I'll explain you the proof. So next class means tomorrow you have test. Tomorrow you have test. So Monday we'll complete this chapter. So yeah. Same. If you write for 1.5 hours, it's 40. I gave it there. So there are only two patterns which should be followed. Whatever is a full mark, okay. 3 hours, how many marks will you write for? Half, okay. That is the pattern. So physics, 3 hours, 70 marks. Now 1.5 hours, 35 marks. That's it. Okay. Right. So those who are online, I hope it is clear.
Sir,
Yeah, tell me. Let's wait for them. Yeah, tell me, Harsha.
sir, on what topic are we having a test tomorrow?
It is on continuity and differential.
Okay.
Okay, you're prepared for it?
Actually, I haven't touched the chapter, sir.
Okay, let's see. You at least try to solve. We'll see.
Yes, sir.
Okay, at least you'll get exposure to questions. Okay. Shall we wind up? Oil. We'll wind up.